So hey guys, uh, welcome to Mastering Cloud and welcome to Mastering Kubernetes series as well. So in this video, I'm going to show you a pictorial representation of the Kubernetes architecture as well as how each of these components are interlinked and how the communication happens between those things. Okay, so without any delay, come on, look at my screen. So like we discussed in the previous videos, there are primarily two components. Two servers or two segregations that we do, which is a control plane and a data plane. So if you look here, control plane is nothing but a server. Okay, any server which has an operating system. So this control plane has few components such as API server, which is the core component of your Kubernetes, which we use it as an interface. So if you want to talk to Kubernetes, if you want to deploy your pods, if you want to provision anything, or you want to get any information of your Kubernetes cluster, so API server is the one that we interact with. So internally, this API server will interact with the various other components within a cluster. But if someone wants to get the information of your Kubernetes environment, the cluster information, anything with regards to Kubernetes, so we always interact with the API server. So once after the API server, we have a scheduler. So this API server and scheduler go hand in hand. So it's like, let's say I want to provision a pod. So how am I going to do that? So I'll tell my API server that, hey API server, I want to provision 2 pods. Could you please do that for me? So API server will do its own analysis. It will authenticate you, basically whether it will have to understand that whether you are authorized person to do this or not. So this is a whole process. So authentication, authorization will be taken care by API server. Okay, which we will discuss in detail in the coming sessions. But for now, understand that you are authorized. Okay, you are authorized to provision 2 pods. Now, this request is taken care by API server, but API server doesn't know where to place them. You might have a 5 node cluster, you might have a 10 node cluster, but where should these 2 pods run, right? So these pods have certain criteria. Imagine this pod requires, let's say, 4 GB of memory, 2 CPUs, okay, or maybe 4 GB of memory, 2 CPUs, and it has some volume constraints. So this information is handled by scheduler. So API server will pass this information to the scheduler, and it's scheduler responsibility to place these pods on the right node, whichever is available in a given Kubernetes cluster. Okay. And then comes the controller. So once these pods are provisioned and these pods are created and they are up and running successfully, now there is always a person who monitors the state of these pods. Let's say, so I have 2 pods now. Maybe one pod is unhealthy, okay, because of which it is continuously restarting. It is getting into a restarting loop. So this is taken care by the controller. So it could be because of the node on which this specific pod is running, or it could be some issue with your application code itself. Irrespective of what it is, so this controller is responsible of making sure this specific pod is running irrespective of the failures. So it will continue to, so for that, it might restart your pod, it might provision the pod on the other available node. Okay, all of this is handled by your controllers. There are various types of controllers available, like node controller, replication controllers, cloud controllers. Okay, so depending on the environment in which you are running, so each controller will be responsible for it. So in simple words, if someone asks you what is the purpose of a controller, so what I would say is that the controllers are responsible of managing the desired state of your components. So it could be a node, it could be pod, it could be a deployment. All of this desired state is managed by the controllers. And now the most important thing is etcd. So I just said now that my job is to provision 2 pods. I did it. Scheduler plays them and controller is taking care of it. But where is this information stored? If someone comes, okay, and query the cluster that, hey, show me all the pods available. So how will API server give me that information? So it relies on the etcd. So whenever you want to provision something, whenever you have provisioned something, all that information is gathered and stored it in etcd database. So etcd, we call it etcd, etcd database, okay, whichever is convenient you can call it, but I prefer calling it etcd database, which is a key value pair database, guys. So this etcd component will store the entire cluster information. So usually we do take the backup of this etcd. In case if something goes wrong, you can always revert back to the previous good configurations. So ideally, when you are managing your own Kubernetes setup, meaning you have your own master server, your own worker nodes, and so we always have some schedule to back up this etcd, because no one knows when there could be failure. So having a backup of your etcd will help you in recovering your cluster from failures. Okay. So I'll try to show you in the future videos on how we can do that. But if your cluster is running in a cloud environment such as AWS, Azure, GCP, you are free from this. So you don't have to worry about taking the backups of etcd and all of this. It is handled by the cloud providers itself. So that's one advantage that you will get when you are hosting your Kubernetes in any of the cloud vendors. And the next important component we have is data plane. So ideally people call it worker nodes, okay, where your pods are going to run. So control plane is dedicated to run only the components of your Kubernetes, such as API server, schedulers, etcd, controllers, and other supporting components of your clusters. And it is not recommended to run your workloads on a control plane. It is a best practice. But if you want, you can override that functionality, and you can also allow your normal workloads to run on a control plane too. But ideally it is not preferred. Okay. So we always run our own pods, your own applications on top of the data plane, that is the worker nodes, but not on the control plane. So this data plane, the worker node, has two major components. One, which is a kubelet. So kubelet acts as an agent on top of your worker node. So this specific agent always communicates back to your API server, which will pass the information. So the information of what is the node status, whether the node is live or not, how many pods are running, what is the resource utilization. So all of this node information, node specific information, is sent back to API server, and that information is again stored in the etcd. So that is how the communication happens. Let's say if your control plane lost communicating to one of the worker node, or when you are looking at the health of your cluster status, sometimes you might see that, hey, one of the worker node is not reachable. It is not reachable state. So that could be because your kubelet service might not be running, or it might not be communicating back to API server. So you will have to, once you restart the kubelet service, it will communicate back to the API server. So if you are preparing for Kubernetes certification, this is one of the questions that you will have. So in one of the cluster, they will make one of the worker node as down, and they will ask you to bring it up. So all you have to do is that log into that specific worker node and then restart the kubelet service, and it will start communicating back to your API server. Okay. So this kubelet also generates huge amount of logs. So while you are troubleshooting, the kubelet logs also play a very major role in fixing the issues as well, guys. Okay. So we will see that. Okay. We will go step by step, but understand that kubelet is an agent which is very responsible, very important and responsible for communicating the information of this specific node back to your API server. And the other thing is kube proxy. So you all might know what proxy server is. I'm assuming you all know what proxy server is. If you feel that you are not aware of proxy server, or you want me to make a video on what proxies are, let me know in the comments. I'll try to put that in the I'll try to make a video on that. But for now, understand that proxy is kind of a security mechanism. So this proxy is responsible of exposing your pods to external world. It is kind of, it acts as a firewall, it acts as a security mechanism layer while you are exposing your pods. Okay, I don't want to confuse you here again. So when we talk about the networking components, I'll try to get, so when we're talking about the networking components, I'll try to get more deep into proxy. But for now, understand that proxy is responsible of exposing your pods to external world, or it can also act as a firewall for you within a given Kubernetes cluster. So now these are the components that we have in your Kubernetes cluster, guys. Apart from this, you might also have some add-ons and all, which I don't want to put it here, but we will discuss them again in the later. So your cluster is ready, everything is good, but how are we going to communicate to our cluster? So let's say you want to do something in a cluster. How are we going to do that? So you might have your own laptop or desktop or any client machine. So you cannot directly talk to your Kubernetes cluster, guys. You need to have another utility, which is a command line tool. So this command line tool is called as kubectl. So this kubectl has to be installed as a commandlet. It is a small software which you will have to install on your client machines. And this kubectl will use a config file, a kube config file. So this kube config file will have the entire information of the cluster, your authentication information, your username, passwords, what cluster you are trying to reach to. All of this information, your permissions, all of this information will be stored in the kube config file, and it will read the kube config file. It understands that, okay, hey, this is the cluster I want to talk to, and it will start communicating to your cluster. Okay, so kubectl is a command line utility for you to talk to your cluster. So this is how the communication happens. Now let's say I want to provision 2 pods. So from kubectl, I can create an imperative command, or I can create a simple YAML file for provisioning 2 pods, and I'll send that information. Hey, Kubernetes, please go ahead and create 2 pods for me. So these instructions are sent to API server. So this API server will pass the information to the scheduler. So scheduler will communicate to the node via kubelet, and it will provision the 2 pods for you. And once these pods are provisioned and this pod information is sent to the API server, and that information is stored in etcd. So this is how the whole cluster communication will happen, guys. Okay, so hope this will simplify your Kubernetes architecture concepts. So let me know in the comments, and I'll be more than happy to explain you in detail. See you in the next video.